For centuries, the physical world appeared to be split by a fundamental divide. On one side, matter is bound to the Earth, plummeting to the ground the moment it loses support. On the other, the moon and stars appear magically suspended in a perpetual weightless void. The historical consensus held that these two environments were governed by entirely different physical laws. The mechanics of the orchard had nothing to do with the mechanics of the heavens. Isaac Newton proposed a hypothesis that unified these two worlds. He suggested that the moon is not simply floating, but is actually falling toward the Earth, driven by the same unseen force that pulls an apple from a branch. This is possible because of centripetal acceleration, an inward-directed force acting on an object with high sideways velocity. Because the moon moves horizontally at such a massive speed, it falls around the Earth. The planet's surface curves away at the same rate the moon drops, resulting in a stable orbit rather than a crash. To prove this connection was more than a guess, Newton had to build a mathematical bridge. He needed to show that the familiar gravity on the surface of our world matched the trajectory of a massive body in deep space. Newton began with the measurable data for the moon's orbit, its distance from the center of the Earth, known as the orbital radius, and the time it takes to complete one revolution, known as the orbital period. This diagram represents the formula for centripetal acceleration. By calculating these orbital variables, we can find the exact numerical acceleration of the moon as it falls toward the Earth. We can then compare this tiny lunar acceleration to the known value of gravity on Earth's surface, the standard acceleration of 9.8 meters per second squared that acts on an apple. The results reveal a precise ratio. The acceleration we feel on the surface is exactly 3,600 times stronger than the acceleration acting on the moon. This number provides the proof Newton needed. The moon is 60 times further from the Earth's center than the apple is. Since 60 squared is exactly 3,600, it confirms that gravitational force weakens in proportion to the square of the distance. This relationship is the inverse square law. It states that as the distance between two objects increases, the gravitational pull between them drops by the square of that distance. The force is also determined by mass. The strength of the attraction is directly proportional to the product of the masses of the two objects in the system. To turn these proportions into a definitive equation, we use the universal gravitational constant, or capital G. This value represents the inherent strength of gravity across the entire universe. Combined, these variables form the Universal Law of Gravitation. This law established that mass itself generates an attractive force. For the first time, a single equation explained the movement of every object in the cosmos, from the smallest stone to the largest planet. Gravity acts as a vector quantity. This means it is defined by a specific magnitude, how hard it pulls, and a definitive direction, where it pulls, when dealing with two objects, but a different approach is required when a system contains multiple masses pulling on each other at once. Whereas movements of entire galaxies are essentially the result of these simple vector additions occurring across billions of stars simultaneously. One final geometric problem remained. Newton's law is designed for point masses, infinitely small dots, but the Earth is a massive three-dimensional sphere. Using a single point to represent an entire planet requires a specific geometric proof. We solve this by treating a planet as a hollow spherical shell. For a mass outside, surface pulls act in different directions. Sideways components perfectly cancel, leaving a central net force. Inside the shell, pulls from every direction balance, resulting in zero net gravity. Because the solid Earth is composed of a nested series of these concentric shells, the math proves the entire planet acts as if its mass is concentrated at its center. This geometric symmetry is what allows the same physical laws to govern both the microscopic and the infinite. It is why a single rule of attraction can describe the motion of an apple in a garden and the path of a planet through the void.